So welcome back, Sanbonani Abufundi. We're carrying on with our study of calculus, and let's dive straight in. We are on page 120, right? And the question says, is this function increasing, decreasing, or stationary? Stationary means going flat when x is 2/3. So we are interested in finding out about its gradient. And remember, to find gradient, we're going to find the derivative. We are going to differentiate this thing to find its gradient function. And its gradient function is 2x minus 2. Not 2x squared, 2x minus 2. Right. Now, when x equals 2/3, our gradient is going to be 2 lots of 2/3. That's 2 lots of 2/3 minus 2. 2 lots of 2/3 is 4/3. 4/3 minus 2 is actually negative 2/3. Now, is that a positive or a negative gradient? That's a negative gradient. So, therefore, decreasing. The graph at that point will be decreasing. It will be going downhill. Okay. This question then says, when does this curve have a gradient of 6? Not what is the gradient when x is 6. When is the gradient equal to 6? Well, let's work out what the gradient function is. And remember how we do that? We differentiate. 2x plus 2. We want that to equal 6. Subtract 2 from both sides. 2x equals 4. Divide both sides by 2, x equals 2. Right, so that's our answer for A. Our answer for B, we want the gradient now to be negative 4. When is our gradient, 2x plus 2, when is that equal to negative 4? Now we're going to subtract 2 from both sides, we get 2x equals negative 6. We're going to divide both sides by 2 and we get x equals negative 3. Right, so our answer for B is x equals negative 3. Okay. Now, let's look at this question, number 9. And again, if you haven't tried these questions, please pause the video and try them yourself. Okay, right. When will this graph have a gradient of 0? Okay, so remember how we find the gradient? We're going to differentiate it. And we get 4x minus 4. Remember, the derivative of 7 is 0. We want the gradient to equal 0. So now we're solving a very simple little equation. Let's add 4 to both sides. And let's divide both sides by 4 and we get x equals 1. Okay, so when x equals 1, that graph has a gradient of 0. Okay, and I'm going to quickly draw that graph for you just to show you what it looks like. Okay, let's type it in. I think it was y equals 2x squared minus 4x plus 7. Okay, now I want you to look at where that graph has a gradient of 0. It starts off with a negative gradient and then it goes uphill. It looks like, absolutely, there it is. At 1, it's got a gradient of 0, which is exactly what we've just found. That's where the graph turns. Okay, now what about this one? At what value of x does this function have a gradient of 0? So now we're going to differentiate ax squared plus bx plus c. Remember that a, b, and c are just constants. So f dashed of x is going to be 2 times a times x to the 1. Sorry, 2 times a times x to the 1 plus b x to the 0, so just b. We want the gradient to be 0. Now let's solve this. Let's work out what value of x will make this 0. We're going to subtract b from both sides. We're going to divide both sides by 2a. And we get negative b over 2a. Now that should ring bells for you. That is a formula that we gave you way back in grade 10 and 11 for the coordinate of the turning point of a parabola. Now we have confirmed that formula using calculus. Okay, right. So we're going to ask you to pause the video try questions 11 and 12 and, yeah, 11, 12 and 13. All right. In fact, let's do 11 and 12. All right. And then we'll have a look at them. Right, let's take a look. Find the equation of the tangent to the curve. Okay, that's a standard question, and we've done loads of these, all right, already. So obviously the point of contact, we've got -1. If we put -1 into this function, now just be careful, we mustn't square -1, we mustn't do the negative of -1, we must square -1 first, which gives us 1. So this still becomes -1 minus 2, so it's -3 minus 5, -8. All right, that is the point of contact. Let's now work out the derivative, the gradient, okay? So we've got f dashed of x is -2x plus 2. When we put -1 into the gradient function, we actually get -2 times -1 is +2 plus another 2 is 4. Right, so what we've got here, we've got some kind of parabola. It's actually an upside down or a sad parabola. We're going to get a new name for that soon. All right, and we know that at this point of contact that the gradient is +4. So our picture looks something like this. Okay, something like that. And we're wanting the gradient of this blue line. Well, I'm going to use the y equals mx plus c version this time. Y is -8 is the gradient times the x value plus c. So -8 is -4 plus c. Let's add 4 to both sides. We get -4 equals c. Our final answer is y equals, okay, our gradient is 4, x, and our y-intercept is -4. Okay, now we talk about a normal to a curve. Now what a normal to a curve is, it's a line, and I'm just going to draw it in on here. It's a line that goes perpendicular to the curve rather than parallel. So a tangent goes parallel to the curve, a normal goes perpendicular at 90 degrees. Okay, let's see if we can find the normal to the curve of y equals x squared at x equals 2. So let's just draw a picture in our minds. You notice we're always trying to look at what does the thing look like. Well, y equals x squared looks like that. Okay, this point of contact is 2, 4. Okay, now we want the equation of this line that's going to go through there like that. Okay, what we know is we know that that red line will be perpendicular to this black line. Okay, can we find, so in other words, there's a right angle in here. Can we find the equation, can we find the equation of the, can we find the gradient of the black line? Because if we can find the gradient of the black line, we can find the gradient of the red line. Yes, the gradient of the black line, we're going to differentiate the curve. So dy dx equals 2x. At x equals 2, all right, we know that dy dx will be 2 times 2. It'll be 4. So this black line, this tangent line, has got a gradient of 4. Okay, now how are we going to find the perpendicular line? Yeah, that's right, we're going to turn it over and change the sign. So this red line has actually, this normal has actually got a gradient of negative a quarter. Okay, the black one is called a tangent, the red one is called a normal. Now what we're going to do is we are going to, this time I'm going to go with y minus the y value equals the gradient x minus the x value. Okay, x minus 2. So, try to improve that and make it worse. X minus 2. Okay, if we simplify this, we get negative a quarter of x. We get plus 2 quarters, which is plus a half. And then we're going to add 4, so it's actually going to be plus 4 and a half. 4 and a half is 9 over 2. Okay, there's our final answer. That's the equation of this normal. Okay, right, you've seen how to do one. Why don't you try one yourselves? Okay, so in fact there's 2 to try. Pause the video again, try B and C, and then we'll go over them, and that'll bring us to the end of today's lesson. Okay, so B. Right, what we know is that f of naught is negative 2. That's the point of contact. 0, negative 2 is the point of contact. I'm now going to work out f dashed of x. F dashed of x is negative 2x plus 4. Now when we put 0 into that formula, we're going to get the gradient of the tangent at that point. So when you put 0 in here, you get 4. Now, what that means is that on this unhappy parabola, upside down like a frown, okay, we have a point here, which is the point 0, negative 2, and we know that the gradient of the tangent is 4. Okay, so this black line has got a gradient of 4. Now we don't want to find the equation of the tangent, we want to find the equation of the normal. Now the normal goes perpendicular, so it's going to go kind of through there. Alright, what gradient will the red line have? Yeah, it's actually the same as last time. It's going to have a gradient of negative a quarter. Remember how we found a perpendicular gradient? We turn it upside down and we change the sign. Okay, so now 0, negative 2. Now 0, negative 2 is, not surprisingly, that point is on the y-axis. So in fact, negative 2 is where our graph cuts the y-axis. So our equation of the normal will be y equals negative a quarter x minus 2. The equation of the tangent would be 4x minus 2. Both of them go through, this point here is on the y-axis, it's the y-intercept. Okay, negative 2 is the y-intercept. Okay, and then this is a kind of more general one, all right, but it's exactly the same idea. The point of contact, all right, well, if we make x 0, 0c is the point of contact. The gradient of this line, dy dx, or y dashed, is 2ax plus b. When x is 0, the gradient is going to be just b. Okay, now what is perpendicular to b? And the answer is negative b, 1 over b. So the gradient of that's the gradient of the tangent, the gradient of the normal we're going to take b over 1, we're going to turn it over, and we're going to change the sign. Okay, and remember that this is the y-intercept. So our final answer is going to just be y equals m that's our gradient, times x plus c, the y-intercept. Okay, right. That's a little bit abstract, but it's just, we're just using variables instead of numbers. Right, we're going to stop there, and we'll look forward to seeing you next time. Right, sometimes questions involve simultaneous equations, and we're going to look at some examples like this next time. Right, but generally speaking in maths, when we are required to find two variables, then we're going to try and set up two equations and solve them simultaneously. Right, have a great day, everyone.